is 3.8 kilometres offshore, and the Hay Point Services Terminal to the south is 1.8 kilometres offshore. To facilitate the growing coal exports, a deep draft channel was commissioned and was completed in October 2006 at a cost of $70 million. Over 1,000 ships load at Hay Point each year, consisting mainly of Handy, Panamax and Cape-size vessels. In 2009, over 83 million tonnes of coal was exported, and by 2013 this is expected to reach 130 million tonnes. The deepwater channel is 10 kilometres long, is 500 metres wide off the berths for a turning basin. It decreases to 300 metres wide at the pair of beacons, and probably more importantly, it's marked by minimal aids to navigation. The channel allows sailing drafts of up to 19.5 metres on higher tides. With regards to being marked by minimal aids to navigation, there are no nav aids off the berth, turning or rear shore leads, and in the channel 4 beacons have been installed in lieu of the standard 6 beacons. For those of you who prefer a more technical view, this shows the deepwater channel, departure channel, and to the north of that, the channel used by the non-deep draft vessels. Reducing the number of navigation aids resulted in significant cost savings, including approximately $8 million in setup costs and approximately $800,000 per annum in terms of maintenance. To compensate for implementing minimal aids to navigation, the system at Hay Point encompasses 2 components. Firstly, the use of portable pilot units, and secondly, electronic substitution for channel markers and beacons. The Hay Point VTS closely monitors each deepwater departure and provides a backup service to the pilot should a portable unit fail. To facilitate monitoring the departure, the channel is highlighted in a way that readily identifies the vessel's distance from the centre line. This is achieved by using chain markings along the track and 50-metre grid lines on each side, either red or green off the line. For example, red 100 means the vessel is 100 metres to the left of the centre line on departure. This system is used only for deep draft departing vessels and was developed jointly by the pilots and the VTSOs. I'll show a replay shortly to show how this works in practice. Those of you can see the chainage markings and the grid lines are used throughout the channel until its very end. The pilots carry on board at times 3 A3 pages covering the whole departure channel. These chartlets are marked with the same chainage and cross-channel grids used by the VTSO to monitor the departure. In setting up for departure, the pilot will set up his or her portable pilot unit, check the vessel's AOS for accuracy, and discuss the departure with the duty VTSO. Upon departure, the duty VTSO will monitor the vessel's transit until the vessel has exited the channel. There are 2 conditions where the system is initiated. The first is where the duty VTSO observes the vessel is diverging from the centre line. In such situations, the operator will contact the pilot and ask for an equipment check. For example, you are showing green 100, communicating that the equipment at the VTS indicates that the vessel is 100 metres to the right of the centre line on departure. The second situation is where the pilot experiences difficulty or failure with the PP unit and requests situational assistance from the duty VTSO. In such instances, the duty VTSO will communicate the vessel's AOS position relative to the change markers and cross-channel grid markers. The pilot will commence plotting the position reported on the paper charts and determine his own course or action to navigate the vessel. The VTS does not provide any advice to the pilot in terms of returning to the centre line. The following replay demonstrates the use of the backup system. This is an example of one of the regular familiarisation tests conducted between the pilots and the VTSOs. So essentially this is taken from one of the simulated tests as opposed to one of the real examples. This is the screen that the VTSO is using to monitor the departure.
Entry carriage at chain 4,250 to range of 30. Okay, I got great. Done now.
And we pause the voice for the rest of this, but essentially between shore and pilot they'll continue calling out the deviations from the centre line for the remainder of the transit, and the pilot will be reporting those manually on those three chartlets given as PPU has failed. From the shore perspective, operating procedures have been developed in consultation with the port pilots, and audits are undertaken at regular intervals to ensure all parties are well versed in the use of the system. I won't bore you too much with the details, but they're the procedures for the VTSOs, and similarly the pilots have complementary procedures for using on board. Both pilots and VTSOs are fully trained in their respective components of the system. The pilots are trained on a full bridge simulator on the use of the PPUs, and the VTSOs are trained in-house and are approved to assist pilots once all training modules have been successfully completed. Since commissioning of the new channel and the associated system, the increase in coal exported at Hay Point has been substantial, yielding an additional 1.8 million tonnes annualised. It has been estimated that up to 15% of this increase in coal exported can be attributed to the system. Since its introduction in March 2007, the use of shore-based assistance has been requested by pilots on 7 occasions due to the equipment failure on board. In summing up the system implemented at Hay Point, it utilises a minimal number of physical aids to navigation, saving originally $8 million plus in setup costs, and annually saving about $800,000 in maintenance costs. It utilises a tried and tested backup system that is assistance from the VTS and these are paper chartlets on board. It ensures that both parties, pilots and the VTSOs, are fully trained and practiced through the use of regular audits and tests. This has provided an environment that's generated considerable trust between the two parties. VTSOs only provide situational awareness, and in this case, not navigational assistance. Well, we've been running this now for 2 years. Both parties have been quite happy with it, and it is reviewed and audited probably every 2 to 3 months. One improvement that they have looked at in recent times is actually adopting a system of electronic corridors. It's a long transit. A vessel may take an hour to an hour and a half to go through the whole channel. This is just one of the enhancements being proposed by both VTSOs and the port pilots. Thank you very much.
Thank you, Neil. Our next speaker is Lieutenant